Did you know Unity has a built-in functionality to check what direction a collision is happening in 2D physics that works for both on-trigger 2D and on-collision callbacks? This method can actually be used to do different things, such as like do item blocks from like Mario games, and you can also do things like one-sided enemy collision, where enemies can only hurt you from different directions, like from the side here, or you can only kill enemies by jumping on them from top. You can also do things such as, like, for anybody that's played Hollow Knight, a little bounce pogo if you ever strike the spikes from above whenever you're jumping above them without taking damage. Unity 2D physics base class for all colliders called Collider2d has a method for getting distance and direction when comparing two colliders during collision unpacks. This function is called distance and returns a 2D physics only struct called Collider2d. I'll put a link to its documentation in the description below for people wanting to know more about it. The Collider2d struct contains information for 2 points. The variables are called point A and point B. These represents the points of collision on both colliders involved in the collision callback. The collider distance also has a struct called normal that returns a vector2 normal calculation of the 2 points that can be used to allow for checking the direction of the collision. Basically, the normal is actually calculated from point B to point A. Do note there's also a distance value that actually tells the distance between the two colliders' center points, and we're actually going to talk about those in a different video and how we can actually use them to do some cool tricks for custom character controllers. We can get the direction of the collision inside of on-collision callbacks by using the passed-in collision 2D collision variable and calling the distance method on the other collider variable inside it while passing in the collision collider as the parameter of the distance call. And basically what this will do, it'll return a vector2 that calculates the normal. And this normal will actually be the direction of our incoming collision. Do be careful. The collision variable that's being passed into the function has two different colliders on it. One is collision.collider, which is the incoming collider that we are colliding with, and then collision.otherCollider, which is the collider this script is attached to. And the reason why is the passed-in variable is basically showing the incoming collision, so the other collider from the perspective of the incoming collision is our script, or our game object that has the collider on it that we're interacting with. So do be note, try not to get confused by that. Thought I'll just give a little section mentioning that as forewarning. Do be warned, in some versions of Unity, on-collision exit 2D reverses the normal, and I'm going to be honest, there is no documentation explaining why from Unity. So whenever you're doing this inside on-collision exit 2D, you need to times it by -1. My guess is the reason why is whenever they're doing the normal, they're actually calculating behind the scenes on the C++ side of stuff. They're actually calculating whether there are two colliders actually inside each other or like touching each other. If they're touching each other, they're actually passing the like a 1 or not from that direction. So that would actually make it where during the on-collision exit 2D, they're no longer touching each other. So we had to flip the values. Just a heads up on that. You would also have to do that inside on-trigger exit 2D if you are needing to use this function. So just to give a little example of how this looks. So basically my player here will be hitting this item block from below. The item block has the collision direction 2D on it. So basically it'll be showing and printing out that the incoming collision is from below, which will be represented by a 0, -1 vector 2. 0 is showing that it's not colliding from left to right, and the -1 shows that it's colliding from below. As you see, I hit the item block and you see that it says -1, -1 on incoming collision. And for the exiting collision, like I said, I had to times that value by -1, and you'll see it works. And to take this a step further, you'll see enemy here, jump on enemy. Since I hit the enemy from below, above, it kills enemy. But let's have the enemy hit me from side, it kills me. So you can actually use this for multiple things. You can use it for item blocks. You can use it for directional collision checking. You can actually use it for Hollow Knight's pogo sticks, which I'll actually do a video on later. And so much more. Do note, for on-trigger callbacks, they pass in a Collider2d instead of a collision2d method. So with the Collider2d, you don't have the other collider variable. So what you need to do is you actually need to do a get component and actually get the collider that's actually attached to your game object. So this would be the item blocks collider, for example. And you actually just say the item blocks collider and you call the distance function on that, and then you pass in the collider that is actually being pushed into the on trigger callbacks, and you just get to normal that. And that's how you do this inside of on trigger. And just like with on collision exit 2D, you had to times it by -1 to get the proper value. Do note for on trigger stay 2D and on collision stay 2D, they work the same way for on collision enter and on trigger enter 2D. The only one that you have to times -1 by is the on exit callbacks. And just to show this off, I'll actually go into Unity. So now I have the box collider as trigger. I'm going to hit play, and boom, it works. So as you see, we have -1 and 1. And do note the reason why the object didn't spawn is I just have actually a separate script for object spawning for on collision and not on trigger. But I want to show that there is a difference. I will be making a separate video for on trigger to show some cool effects for like room controlling for like Metroidvanias and portal systems to help out. For anyone wondering about the item block script, here it is. Basically, I'm just checking to see if the item block is already spawned, if the thing I'm colliding with the item block is the player, and if the spawned object is not null. And then I basically check to make sure if the direction is down. If it is down, then just spawn the object. I'll be going over this in a little bit more detail in this new video. And basically that new video will actually show different things you could do with the distance function. Example would be Metroidvania room system. So loading like a 2D Metroidvania game like Hollow Knight, and how you actually transition from one room to another room with camera collision controls, like being locked into another room. Another thing I'll actually be showing is how you can do like a P button system like in Mario style games, or how you can do like pressure plate systems where you push a box over a pressure plate and you have that plate actually open up a gate while the pressure plate is being held down. And I think I might actually show how to do like Hollow Knight's pogo thing. You know, I'm also going to be showing how to do a portal system. So imagine like you go through portal, and basically showing you how to actually choose the correct side of the portal to teleport on. Because a lot of times whenever people are doing portal systems, when they first start out, they'll just have like the player spawn in the center of the portal. You might actually have some issues where if that portal is two-way, you might just get rejected right back into the portal, because now you're doing on collision on the second portal and you just create an infinite loop. So I'm going to show people how to do basically see which side of the portal you're colliding on, and actually choose to have you spawn on the right side of the exiting portal. But if you guys like this video, please give it a like, subscribe. If you have anything that you might want to know more about, feel free to ask me in the comment section. I'll be doing quite a bit on the 2D physics side of things. And then I'm going to be also doing, after 2D physics, I'll be going towards like camera systems and full-blown like RPG elements. Basically, my goal for the channel is to show how to do like a full-blown like Metroidvania or like platforming style game in the end. Alright everyone, that's the end of the first video in my physics series. Hopefully by the end of the physics series that I'll be putting out, you guys will be able to do a fully customizable Metroidvania character controller with advanced controls. The end goal is to basically make it where people can do like gliding, flying, ladder climb system, hang system, and basically like water physics and so forth. So this will be quite a bit of series, I would say. The end goal is to not only be able to just copy down and regurgitate code that you see in a video, but also learn the foundational information needed to actually create and tweak your own custom character controller. But everyone, will be the end. See you guys next time.